Hi, so we got a new problem here. This is the second problem, and then we will try to solve that problem about the bungee jumper. The consistent problem that we keep on talking about starting from the very beginning. Now this problem is it's in your screen right now. I will just try to read that one. Determine the drag coefficient needed so that an 80 kilogram bungee jumper has a velocity of 36 meters per second after 4 seconds of free fall. Note that the acceleration of gravity is, well, 9.81 meters per second squared. And we will use bisection again and false position and start with initial guesses of this XL point equal to 0.1 and X equal to 0.2 and iterate until the approximate relative error falls below 2%. Okay, so I don't want to go into details with the derivation of that equation, but if you could remember, this problem, the equation of this is something like this. Velocity is equal to the square root of g m over the drag coefficient times the hyperbolic tangent of the square root of the GCD over m, and then multiplied by t. Okay, so like that. So it's actually like that. Okay, hyperbolic tangent of this. Okay, times t. Now, to determine the problem here is asking for the value of the coefficient of drag, given that the mass is 80 kilograms, g is 9.81. Time equal to, what is this? 4 seconds, and the velocity of with a velocity of 36 meters per second. So as you can see, the unknown here is CD. We will compute that coefficient of drag. So before we proceed, we will try to write this equation first. It would be easier to do that. But actually, do not start here immediately. Do not use this equation and then that is your f of watts CD, for instance. Do not do that. Rather, we will make this function, we will rewrite, okay, from this function, we will rewrite that one into this manner. Square root of gm over cd, like that, times hyperbolic tangent of this square root of gcd over m times t minus v of t is equal to 0. You make the equation like this. You compute this function, you subtract this one here and equal to 0, and then what is the value of CD that will make this function equal to 0? That's actually the coefficient of drag that we are looking for. Okay, do not just equate this immediately. Now, to do that one, I think it's better to put some, this is just an approximation. I will just write the values, 9.81 times 80, okay, for instance, over CD, times the hyperbolic tangent of square root GCD 9.81 times, CD over M is 80, times time, which is 4, okay, minus 36 is equal to 0. So the unknown here is just simply the drag coefficient, the coefficient of drag, that is the unknown. So we will compute that one using bisection and false position. That's what I'm saying. So this is the function. So actually this one, that one, let's just call it function of, what is this? We can actually write function of CD actually. Okay, let's just do that one to make it better. Okay, so this function of CD should be equal to 0. Okay, like that. Now, our guess, according there, is that XL, by the way, and XU, in this example, that is 0.1, and this is equal to 0.2. Refers to the CDL. Okay, the lower limit. And this one is the lower limit, the upper limit of coefficient observed, like that. If we will use f of x here, that is not a problem also, just write, try to remember, we can also write here, if we let x is equal to cd, that's not a problem. And then this whole thing here, it will become a function of x, and then it will become equal to 0. So we will just, we can do that, it's not a problem. Okay. Now, from here, we will start our first approximation. But before that, point 1, point 2, let's try to check it first. So test if a root, if a root exists. Okay. So to do that, we will check f of xl is equal to f of point 1. Okay, and then we will check this one, and then f of xu equal to f of point 2. We will also check this one. Okay, so let's try to do that. I will use my calculator. I have here a hyperbolic tangent, so I can just do this easily. Remember that CD here is x. Okay, we'll just let that one. So I will do that. 0.81 times 0.1 divide 80 in square root times 4, then hyperbolic tangent of the answer, okay, times square root of 9.81 times 80 divided by 0.1. Okay, so the answer is 36.86. The answer is 8603 approximately. Okay, and then f.2, if you want to check that one too, I can do that. 9.1 times 0.2 divide 80, square root of that times 4, then hyperbolic tangent of the answer times square root of 9.1 times 80 divide 0.2. Okay, the answer here is 34.802, 34.8026. But then I forgot, I need to subtract 36 here, minus 36 here, so this is really 0.8603, and this one is negative, well, minus 36 is negative 1.1974, okay? So that is now the values, and then of course, since f of xl times f of xu is less than 0, then we can say that there is one root that will satisfy this function. From there, you start for the first iteration. Okay. So simply we will just write here xr1 is just xl1 plus xu1 over 2. Quite simple, really. We will put here a 0.1 plus 0.2, yes, over 2. Then xr1 is simply what? 0.3 over 2, that's 0.15. 0.15, okay. So that is our root. And then after that, we will check it. We will test first before we move to the second iteration. Okay, we can test this one. Test. By the way, let's write here properly. I will do like this in order that we will not be confused. This is our lower root, this is our upper root. Okay, so that I will not be confused. Now here in this test, we will see f of xl times f of xr. What is this? F of xl here, the lower root f of 0.1 times f of 0.15. Okay? F of 0.1, as you can see, that's 0.8603 times f of 0.15. We will try to do that. We have 9.81 times 0.15 divided by m, which is 80, then square root times 4, then hyperbolic tangent of this, okay, times square root of 9.81 times mass, which is 80 divided by 0.15. Okay, so the answer is 35 minus 36, negative point. So the answer here is negative 0.2045. And this is less than 0. Okay, I think we knew what to do. We will set XU2 equal to XR1. Okay, we will set that one. And so our in the second iteration, we will write here second iteration. This will be our new boundary now, 0.1, and then here is 0.15. Okay, it would be easier so that we will not be confused later. And so after that, we can write the new root. We can compute that one. Yeah, okay. XR2 is equal to XL1, 2 plus XU2 over 2. Okay? And then after here, let's compute 0.1 plus 0.15 over 2. How much is this? Okay, so plus 0.15 divided 2, that's 0.125. 125. Okay. And then we can compute the error now. Error is equal to current value 0.125 minus 0.15, okay, over 0.125 times 100%. So this is what? 0.125 minus 0.15 by 0.125 times 100 is still 20%. Still very big. Okay. Next, we will move on to the third iteration. Okay. So third iteration, okay, and then test first, okay. So we will execute this one. This test, we will say f of xl times f of xr. What is this? F of lower boundary 0.1 times f of 0.125. Okay. So we know that 0.1 is already equal to 0.1 is here 0.8603 8603 times whatever this value is. So let's try to compute this one again. 0.125 21 times 0.125 divided by 80 times 4, then hyperbolic tangent, and times square root of 921 times 4 times 80 divide 0.125 minus 36. The answer here is 0.3184. 0.3184. So this is greater than 0. So we knew what to do. This is we will set here what XL3 is equal to the XR2, which is simply 0.125. Okay, this is it. And then therefore our new bracket now, 0.125 to what? Here, 0.15. Okay, and then we will continue. So we will solve here. XR3 is equal to XL3 plus XU3 over 2 is equal to 0.125 plus 0.15 over 2. So XR3 is simply equal to 0.125 plus 0.15 divided to 0.1375. Okay, and then lastly, we can compute for the error. Current value 0.1375 minus 0.15 over 0.1375 times 100. EA is equal to 0.1375 minus 0.15 divided by 0.1375, 100. Then error is 9.0909%. Still greater than the stopping criterion. And so we will continue to the fourth iteration because it's the third iteration. But we will just use MATLAB to do this one because it will take time for me. Okay. So, well, this is it using bisection. Okay, so let's try to use MATLAB to continue the problem, and then we'll solve it here. Because we were not able to finish it in the Blackboard because maybe it will take some time, or it will take a few more iterations to solve this problem. Now, before we do that, we need to define first the variables if we could remember those the function. So write mass here. Mass is equal to 80. Okay, like that. Can do that one, and then mass equal to 80. G is equal to 9.81. What else? T is equal to 4. Is equal to 4, and lastly B is equal to 36. Okay, and then we write a function. Let's just say f. We will make an anonymous function is equal to at here x. Okay, assuming that the coefficient of drugs is equal to x, and then we will write the equation. So the equation is, if you remember, that is the square root of gm of no, no, g times m over x, okay, times hyperbolic tangent of the function. So if you could remember, how do you do this one? We can use tan h. Okay. That's the hyperbolic tangent, okay, of the function. So you see this one, this help here, it came out. And then the square root of g times x over m. Okay, and then times t. Okay, close, and then this is it. Yeah. Okay. So f is a function of these terms, g, anyway, these are all constant. So we will call the function bisect. Let's call it. Let's open this one first, by the way. Okay, right click here and then click open. It will open the bisect.m here. And then we will click here. Everything is, well, it's already been inputted. Okay, let's do it. So root EA iter, and then is equal to bisect, and then here we have the func. We will input the f. XL there is 0.1, and then 0.2 for the XU. The second criterion is 2. Maximum iteration, we can make it 50 if you want, and then close here. Then open. Oh, oh yeah, I'm sorry, I made a mistake with the function. Okay, let's do it again. Yeah, okay, here. There's no sign change. Yeah, that's correct, because I forgot to write here minus 36. Okay, here. 36. I think that is the function. Minus v, or let's just say v. Okay, let's do it again. Okay, it's updated now. And then let's just use up arrow to call that one, and then hit OK. Okay, so look at this one. Bisection, the first root is 0.15. Next is 0.125, 0.1375, 0.14375, and then 0.140625 until such time at the sixth iteration the root is 0.1391, and then the second criterion is what I am, yeah, the error, relative error, is 1.1236 at the end of sixth iteration. Okay, so well, I hope you understand this one, and with that, thank you.